Welcome to Draft and Dialogue. Today, we're going to learn an important topic in engineering graphics. First angle projection of straight lines and planes. This concept is the foundation for visualizing objects in 3D and converting them into accurate 2D views. It's not only crucial for exams, but also for real-world applications in design, drafting, and engineering practice. Many students struggle with it, but don't worry, I'll guide you step by step in the simplest way possible. Before we start solving problems, let's first understand what first angle projection actually means. In this method, the object is placed in the first quadrant. Which means it lies above the horizontal plane, HP, and in front of the vertical plane, VP. The projections are then drawn on the planes opposite to the object. In this lesson, we will cover projection of straight lines inclined to horizontal plane, HP, and vertical plane, VP. Projection of planes such as rectangles, and finally, how to locate their traces.
Let's begin with straight lines in projection. First, remember a simple rule. A straight line is always defined by its two endpoints. Let's call them P and Q. Now, when we want to project this line in orthographic views, what do? Very simple. We project the endpoints onto the reference planes. The vertical plane VP gives us the front view. The horizontal plane HP gives us the top view. The XY line is the reference line in projections. It represents the intersection of the vertical plane and horizontal plane. On the sheet, we draw XY as a horizontal line. Above it we place the front view. And below it we place the top view. It keeps both views aligned and connected. Case 1. Line parallel to both HP and VP. Here, the line is not inclined to either plane. So, when we project it, we just drop the perpendiculars from both points P and Q onto HP and VP, in both the front view and top view. Once we place P and Q on both planes, we just join the points to represent the line. We connect those points. Since the line is parallel, it will appear in its true length in both views. That's the easiest case. Case 2. Line inclined at 40 to HP. Now let's make things a bit more interesting. Suppose our line PQ is inclined at 40 to the horizontal plane HP. Here's how we handle it. First, we fix one endpoint. Say P, we locate it with the given distances from HP and VP. From point P, we draw the second endpoint Q, such that the line makes 40 with HP. Now, we project P and Q onto the two planes. When we join the projected points, the line appears shorter in the view where it is inclined. This is important. The true length will not be visible in the inclined view. To measure the true length, we need either the auxiliary plane method or by rotating the line until it becomes parallel to the plane. So, in summary, parallel line true length in both views. Inclined line true length only by auxiliary or rotation method. That's the basic foundation of projecting straight lines in orthographic views. Projection of planes. Now let us talk about planes. A plane is a flat surface like a rectangle, square, circle, or polygon. It has no thickness. In projection, we often talk about two important terms. Horizontal trace HT, where the plane meets the HP. Vertical trace VT, where the plane meets the VP. Let's take an example. Imagine a rectangle that is inclined to the VP but parallel to the HP. Step 1. Draw its top view first because it is parallel to HP. The top view will show the true shape. Step 2. Project downwards to get the front view. Step 3. Notice how the rectangle appears distorted in front view, but remains true in the top view. This method applies to all plane figures, circles, pentagons, hexagons, etc. Thank you for watching this lesson on first angle projection of lines and planes. In the next class, we'll solve problems on projection of solids, which is another very important exam topic. If you found this helpful, don't forget to like, comment, and subscribe, and let me know in the comments which problem you want me to solve next.